Good day. In this video, we are going to do question 2E of the 2022 NCEA Level 1 Apply Algebraic Procedures in Solving Problems, or MCAT for short. Without further ado, let's try to solve this problem, and this is an excellent question. The number of small squares used in an N shape of a pattern is given by the formula n squared minus 2. Show that the difference in the number of small squares used between two consecutive odd number shapes is always divisible by 4. Okay, so the first odd number, let the first odd number be 2n plus 1. Okay, so 2n is an even number, plus 1 will give you an odd number. So the number of small squares in the first even number, which is 2n plus 1, is given by this formula, 2n squared minus 2. So the form is going to be 2n plus 1, which is your 2n plus 1 is your n squared, okay? And then you minus 2. So the next odd number will be 2n plus 3, because the next odd number is always 2 more than the previous one. If it is 5, the next number is 7, so you're going to add 2 more. So 2n plus 1 plus 2 is going to be 2n plus 3. So the number of small squares in the next odd number is going to be, using this formula again, 2n plus 3 squared minus 2. So we have two equations now, and the difference in the number of small squares used between two consecutive odd numbers. So you take this one minus that number, so 2n plus 3 squared, okay, minus 2, that number minus the first number, 2n plus 1 squared, okay, minus 2, and we are going to show that it's divisible by 4. To do that, we need to expand this expression and cancel out the common factor. Okay, so 2n plus 3, when you expand 2n plus 3, when you expand 2n plus 3, okay, we do a grid method, it's going to be 4n squared plus 6n plus 6n plus 9. So simplify, 4n squared plus 12n plus 9. Okay, 12n squared. Okay, so it's going to be, this expression is going to be 12n squared. No, it's going to be 4n squared plus 12n plus 9 minus 2, because don't forget we have a minus 2. Okay, minus the second expression is going to be the same thing. We're going to expand again, 2n plus 1, 2n plus 1, it becomes 4n squared. You multiply them, it becomes 2n, 2n again, and then it's going to be 1 plus 1. Okay, simplify them, it's going to be 4n squared, add them up together, plus 4n plus 1. So that part is going to be 4n squared plus 4n plus 1 minus 2, because there's a minus 2 there. Okay, we're going to simplify that expression. So it'll be 4n squared plus 12n plus 7. That's the first part. The second part is going to be 4n squared plus 4n minus 1. Okay, we are going to simplify them. So we're going to open the bracket between 4n squared plus 12n plus 7 minus 4n squared, minus and a plus become a minus 4n plus 1. Okay, now we're going to simplify by cancelling the common factor. 4n squared minus 4n squared is going to be 0. So you have 12n minus 4n going to be 8n. 7 plus 1 is going to be 8. Simplify them, it's going to be, I bring it below, 4 bracket 2n plus 2. So the question asks you, is this divisible by 2? Yes, it is divisible by 2. This expression is always divisible by 4, sorry, not by 2, by 4, as it has a factor of 4. So if 4 4n, 2n plus 2 is always divisible by 4 because this can cancel out, and no matter what, your answer will always be 2n plus 2. This is an excellent question. So if you can understand this, well done, because this is the hardest question in the whole paper. Cheers everyone and have a good day.